Okay, so we have this interesting exponential equation in which the exponents have logarithmic terms. So let's get right into it. So we have it here, 9 raised by 1 plus log x base 3 minus 3 raised by 1 plus log x base 3 minus 210 equals 0. So let's just simplify the 9 raised by 1 plus log x base 3 and the 3 raised by 1 plus log x base 3 and then find out what we'll get. So, but the best way to simplify them is to still apply the laws of indices, where you have a raised by x times a raised by y equals a raised by x plus y. So having this one now, reversing this back to this, or being able to reverse this back to this, will give me an edge here, because I'm going to reverse this back to something like this. So following this pattern, I can reverse this to something like this. So I'm going to have it like a raised by x became a raised by x times a raised by y here. So I'm going to use that logic here too. So this one that becomes 9 raised by 1 times 9 raised by log x base 3. I'll do the same thing here too, minus 3 raised by 1 times 3 raised by log x base 3, then minus 210 equals 0. Of course, if you multiply back, you get this, because you have to pick one base and then add the power. So we are doing the right thing. So 9 raised by 1 is still 9 times, of course, this is still 9 log x base 3 minus 3 raised by 1 is 3 times 3 log x base 3 minus 210 equals 0. I can further simplify this one, so just at least make it look like this. So I can make this 9 3 raised to power 2. So I now have 9 times this 9 becomes 3 raised to power 2. The aim is to make it be identical to this expression here. Then all raised to power log x base 3 minus 3 times 3 raised to power log x base 3 minus 210 equals 0. Of course, the powers can multiply. 2 times log x base 3 gives me 2 log x base 3. So I have 9 times 3 raised to power 2 times log x base 3 gives me 2 log x base 3 minus 3 times 3 log x base 3 minus 210 equals 0. And of course, the 2 here can move over and become a power for x, becoming x squared. So I now have 9 times 3 raised to power log x squared base 3 minus 3 times 3 raised to power log x base 3 minus 210 equals 0. And then looking at this part of the equation and this part, you will notice that the main base and the logarithmic bases are the same. Likewise here, the main base and the logarithmic base are the same. So I'll apply this law where you have the main base and logarithmic base the same. Then you have the number of the logarithm being your final answer. Even here, you have the main base as 5 and the logarithmic base as 5. Then you have 6 as your final value. So the number 6 here becomes what you get when you evaluate this. And this one also, you get B when you evaluate this. Remember, the main base and the logarithmic base has to be the same for you to have the number for the logarithm as your final answer. Even this one. So here, 9 times the main base and logarithmic base are the same. So x squared is my final value there, minus 3 times, again here, the main base and the logarithmic base are the same. So x is my final value there, minus 210 equals 0. And of course, if you multiply, 9 times x squared gives me 9x squared, minus 3 times x gives me 3x, minus 210 equals 0. Then dividing through by 3 to make the quadratic equation look more simplified, you will get 3 in 9 is 3. You have 3x squared. This one is 3, so you have 3x squared. And 3 cancels 3, you have x, so minus x. Then minus 3 in 210 is 70. So minus 70 equals to 0 divided by 3 is definitely 0. So this is a quadratic equation, and then I'll solve by factorization method. That's going to work. So draw your table and let's see how that will work. Multiply this by this. This is the constant. So minus times plus is minus. 70 times 3x squared gives me 210x squared. Then what I'll put here is the whole term here, which is minus x. And then I'll think of two numbers I'll multiply to get minus 210x squared, and then I will add to get minus x. And those two numbers are minus 15x plus 14x. Because if I multiply this, I get this. So minus times plus minus, 15 times 14 is 210, x times x is x squared. Then minus 15x minus 14x gives me minus x. So these two values, they are going to replace my minus x here. So I have 3x squared. I'm not writing this one down, I'm replacing this with this whole term. They are coming in here, minus x plus 14x minus 70 equals 0. So I have finding the HCF here, because I'll pick them in twos. So for 3x squared minus 15x, the HCF is 3x. Then if you open the bracket, because now you have to factor out, you have to factorize. So 3 cancels 3, x cancels one of the x, you have x. Minus divide plus is minus. X cancels x. 3 in 15 is 5. Close the bracket. Plus the HCF of these two is 14. You open your bracket. 14 cancels 14, you have x left. Minus divides plus, you have minus. 70 divided 14, you have 5 equals 0. And then you refactor again. You have x minus 5 times 3x plus 14 must give 0. So it's either x minus 5 equals 0 or 3x plus 14 equals 0. And then solving this, you have 3x equals 0 minus 14. Of course, you're moving plus 14 to the other side. You have 3x equals 0 minus 14. You're left with minus 14. Divide both sides by 3. You have x equals minus 14 over 3. That's the first value. Or you just have x equals 0 plus 5. Of course, minus 5 becomes plus 5, and x equals 5. But looking at these two answers, this will not be valid because it's an extraneous root. If you're fixing minus 14 over 3 into this equation, imagine you put minus 14 over 3 here. In fact, this term alone will give you a complex value. It's going to be undefined, actually, if it gives you a complex value. So our real answer here is just x equals 5. So 5 is the only root that satisfies this particular equation. So that's it. Very simple.